task number 6, I'll first of all access the second goal in course goals by its index with this square bracket notation. And the index here is 1 for the second goal. And we can change this to learn all the details, something like that. Now we should also add a brand new third goal. And for this, we can set course goals equal to the result of calling append. And append, as you learned, is a built-in function that operates on slices and allows us to add brand new values to slices. And here I want to append 2 course goals and append a brand new third goal, which is learn all the basics again, maybe. So we overrode learn all the basics with learn all the details, and then we add learn all the basics again as a third element. And now with that, if we print our course goals here after changing those goals, if we run that code, indeed we now see we have learn go, then as a second goal, learn all the details, since we changed that here, and then as a brand new third goal, learn all the basics. And as explained, behind the scenes, Go did create a brand new array for us, basically ditch the old one, and bind this slice to that new array. That all happens behind the scenes for us. We don't have to worry about it. Now in task number 7, I now got a bonus task here that involves a struct, a product struct. And therefore we first of all need to define this struct. So maybe here, right at the beginning of the file, I'll define my product struct as we learned it, give it an ID, which is maybe a string, a title, which might be a string, and then a price, which could be a float. And that's what we did before in the course already. Now we got the product struct. Now I want to create a dynamic array based on that struct. I want to create a dynamic list of products that contains at least 2 products right from the start. And then we want to add a third product to that existing list of products. That might sound overwhelming, but thankfully it's actually not difficult. Here for task number 7, I'll add my products variable. And here I want to contain a dynamic array. So we need a slice. So we need empty square brackets. Then the data type is not string or float or int, but it's product. And I mentioned this before already. You can create arrays that contain structs or even other arrays. You are not limited to the primitive value types of numbers and strings. Storing structs in arrays is absolutely fine, and that's what we'll do here. So this syntax now creates a slice, a dynamic array that contains products. And we can now initialize it with some product data by using the struct literal notation here to add brand new products with an ID of first product maybe, keeping the order defined here when I set up the struct. Alternatively, we can assign values by using the keys again, but here I'll just keep the order, add a comma, and add a first product as a name here, as a title, and then as a price $12.99. Since this can get a bit tricky to read here, we are also allowed to split this across multiple lines as long as we add a comma here at the end, and then even split the struct creation into multiple lines, and also add a comma here in line 44. And now if I reformat this, this is more readable. Now that's one product. We can now copy that and add a second one. So the second product, where I say a second product, and this has a price of $129.99. And that's now my products list, my dynamic list full of product struct instances. Of course, we could have also created those instances in variables ahead of time and then just added those variables into that list, or we do it like we do it here, all in one go, just in time. Either way is fine. And now, of course, we can again print our products like that. Now, when I save that, you'll note that I have some yellow squiggly lines here that tell me that I have some redundant type here. Now, it turns out, And that is something you can't know, but it turns out that when you create such struct literals inside of such an array, which already is defined to only contain these kinds of structs, you can omit the struct name here and just create the structs like that. Since Go already knows with certainty that this list will only contain products, because you clearly define it here. So then you don't need to repeat that type name here when you create the struct instances, even though you are allowed to do it. But it's redundant, so you can shorten the code to look like this. And now with that, we're creating that list of products, we're outputting it, and hence if I run that code, we see our product list down there. Now, since it's a slice here, and hence a dynamic array in the end, we can also solve this last part of the bonus task where we should add a brand new third product. And for this, we could create the product just in time or actually create a new variable that contains it. This is up to you, where I create my product with that struct literal notation. Now we need the struct name again, because here it's not clear that we'll have a product struct in this variable, because we're just creating the variable. And then here I'll give this an ID of third product as a name, and give this a price of $15.99 maybe. Don't forget the comma at the end here to be allowed to structure it across multiple lines. And then we can append this new product and change our product's variable to be equal to the result of calling append on products, where we do append this new product now. And then if we want to, we can also again print this updated products array. With that, if you save everything and you run this, you now find that updated list down there, which contains that third product. And that's now also the bonus task solved. Maybe you also were able to come up with that. Maybe not with that shorter syntax here, but with the rest of this task. And if you did, great. If you didn't, no problem at all. We haven't seen this before, and now you did see it. You now also know that you can store structs in arrays and how that works in detail. Now, before we dive into maps, which is another interesting kind of data structure, there is one special syntax which I want to show you, which is especially interesting when you work with arrays and slices. Specifically also when you work with append. Append actually does not just take one value that is appended, instead you can append as many values as you want. So here we could also add a couple of other values here, as many as we want. There is no limit at all. So it's really up to you. Now, that's good to know, but the key syntax that I want to show you is indirectly related to that. Sometimes you have an existing slice and you want to append another slice or array to it. Let's say here we have our discount prices, and that's a brand new list which I create here, a brand new slice, let's say, which I'll copy from up there, which contains totally different prices. Something like that. Now we might want to merge discount prices into this prices slice. Of course, here it's just an example, but it is highly realistic that you will have some applications that need to merge different lists. For example, existing users with a list of brand new users that signed up during the day. And you can use the append function to perform such merges as well. Now, for that we can reassign prices and call append again. And now you could think that you just append discount prices like that. But if you try that, you get an error. And the reason for that is that you now try to add a slice, so a list of floats, in a place where a single float is allowed. Because prices is a list of floats, not a list of lists of floats. And discount prices is a list of floats. So adding the full list as one item into that existing list is not valid. Instead, we have to kind of pull out the existing items. And there is a special operator in Go which you can use for that. You can add 3 dots here after discount prices, exactly 3 dots, to instruct Go to go to this list and take out all the elements in that list, so these 3 prices, and add them as separated, comma separated elements to this append function, so to say. So that is an important syntax that allows you to pull out all the elements of a list and use them as separate elements in a place where separate elements are needed, like here for append. We can add as many values as we want, but they need to be separate elements. And that's what we create here with this operator. And therefore now, if we print our updated prices thereafter, after using this special operator, if we run our code file here, you see it's a long list of prices and it includes these prices here at the end.